Okay, so today we are looking at polynomial vocabulary. Here's the warm up for today, guys. You're simplifying. You're doing operation with radicals, which is what we've done in the previous lesson. So we have multiplication on one, two, three, on three of them, and then the bottom two are adding radicals, expressions, and the last one is subtracting. Make sure that you complete the warm up on your warm up sheet. Let's take a look at the learning target and success criteria. Let me try to blow this up a little bit because this is too small. Okay, so our learning target is we are learning about the parts of polynomials, in particular the polynomial vocabulary, and determine if the polynomial is a function. Here's the success criteria. I can determine if a polynomial is a function. If it is not a function, if it is not a polynomial, I can state why the function is not. I can write polynomials in standard form. I can determine the types of functions based off of its degree, also known as the exponent. I can identify the terms and types of terms. I can identify the leading coefficient, and I can identify the constant term. So this entire lesson is heavy on vocabulary. This slide, guys, you're going to complete or fill in your foldable. So inside the foldable, you guys are given fill in the blank sections. And so inside, you're going to fill in the blank. And so your foldable, even though this is backwards, it'll look like this, where it has terms, monomial, binomial, polynomial. You're going to fill in your foldable. You're going to fill in the blanks on the inside, and then on the right hand side, it'll ask you for examples, and you'll write the examples on the right hand side. Okay. So again, pause the video at this time to fill this in. But here's some of the main vocabulary. The first one we have is term. The term definition says the term of a number and variable. The next vocabulary word we have is like term. It says terms with the same variable and to the same exponent. And the examples we have here is 7x and 2x. The example we have a term is 4x minus 7 is equal to 5. Then we have monomial. It's an expression with one term. The examples we have is 3x squared and 3xy squared. Then we have an expression with two terms is known as a binomial. The examples we have here is 3x squared plus 2 and 5x minus 1. The next definition we have is trinomial. Tri as in 3. It's an expression with three terms. Examples they give you is 5y squared plus 3x minus 3. And then the other example we have is 3x squared minus 3y squared plus 2. And then finally, we have polynomial, which is what this unit is on. An expression with four or more terms. An example you have is 5xy squared minus 3x plus 3y to the third minus 3. So again, pause the video at this time to fill in your blanks and then write your examples. All right, so now we should be on the graphic organizer. You guys will be given a graphic organizer during class time. And at the very top of the graphic organizer, you'll see it says polynomial function. Here's where you'll write your definition. So it says a polynomial function, as a polynomial is the monomial or the sum of monomials with all exponents as whole numbers. So the one thing that I definitely need you to write is this part that is starred, and I'm going to also highlight it. All exponents are whole numbers. Okay. So it's only a polynomial if all exponents are whole numbers and if the coefficients are real numbers. And remember, we went through the real number system. But the biggest part is that if the exponents are whole numbers. Okay. So that's the biggest thing. Here's an example of a polynomial function: x to the third plus 6x squared plus 12x plus 8. Again, pause the video at this time to fill in your definition. Okay, so now we're going to look at several examples. At the top, just again, we're still following the graphic organizer. And the question is it a polynomial? So f of x is equal to x to the third plus 3x. Let's look at the exponents. We have a 3 and then a 1. If it's nothing there, it's understood 1 as the power. So yes, for this one, it is a polynomial. The next one, b, we have x to the fourth plus 3x minus 2x squared minus 5x. Because this exponent here is a variable, which is not a whole number, no, it's not a polynomial. The next one, we have 6x to the fourth minus 2x to the negative first plus x. Again, here we got a power to the fourth, we got a negative 1 power, and then x is just 1 to the first power. So because this exponent here is negative, guys, it's no, because remember it has to be a whole number. And here's the final example. We have negative 0.5x plus pi x squared minus the square root of 2. Okay. Looking at just the exponents, x to the first, x to the second, and then there's nothing here, it's x to the 0. In this case, yes, it is a polynomial. So pause the video at this time to fill in this section of your graphic organizer. Now, the next biggest thing we have is standard form. The definition is the terms of a polynomial are in standard form when they are ordered from left to right, and you can either write decreasing or descending, whichever one you prefer, which means that it's from the largest to smallest exponent. Okay, so standard form means that you're writing it from highest to lowest exponent. Pause the video at this time to fill in the definitions, fill in the blanks for standard form. All right, now we're looking at degree. Guys, you will have to fill this in. So you're going to fill in the blank, but you're also going to write the types of degrees. The largest exponent of polynomial, that is considered the number of solutions. So let's look at this example. We have negative 7x plus 9 minus 4x squared. So 2, this exponent is 2. Okay, because 2 is the largest exponent because x to the first, this is to the 0 because there's no variable there, and this is to the second. 2 is the largest exponent, that will be considered a degree. You will have to add this on your notes, guys. This is how you classify the exponents or the degrees. X to the 0 is considered a constant. X to the first is considered a linear function. X to the second is quadratic. Um, X to the third is cubic. X to the fourth is quartic, and I think of quarters or quarts. And then X to the fifth is quintic. Okay, so you will have to add this chart at the bottom under your graphic organizer. Say classifying. You have to fill this piece in. Please pause the video at this time to fill in this section of your notes. All right, now we're looking at leading coefficient. The leading coefficient, by definition, is the first coefficient once it is written in standard form. Please make sure you fill in the blank. Another vocabulary word we have is constant, and constant is the term without a variable. Okay, so any number without a variable, number 5, 8, 9, 12, 15, those are considered constants. It does not have a variable. We're going to do, I'm sorry, let's go back. Pause the video at this time to fill in this section of your notes. We're going to go ahead and go through several examples. I'm going to go ahead and shrink this so I can fill it in. Okay, so the very first thing we want to do is write this function in standard form. So remember that the definition of standard form is from highest to lowest exponent. So the first or the highest power we have is 4. Our exponent degree is 3. Then we have 2, and then we have 0. So to rewrite this in standard form, they already wrote it here, but I'll write it again. We have negative 3x to the fourth. Then we need to the third power. So this will be plus 12x to the third. And then we need to the second power. So it'll be plus 2x squared. And then finally minus 4 because that's to the 0 power. And remember that if it's a constant, guys, it's a 0 power. There's nothing there. Then once we have it in standard form, we're able to answer these questions. So the highest degree, okay, is 4, and we name that degree by its exponent, which is quartic. The leading coefficient, which again is the coefficient in front once it's in standard form, is going to be negative 3. And then finally, the constant, which is the number without a variable, right here, it'll be negative 4. Okay. And then you do the same thing for the next example. We need to rewrite this in standard form. Remember that because it's an x, it's an understood 1 here. The exponent is 1. So if I rewrite it in standard form, you'll put negative x plus 3. Okay. Now that it's in standard form, you need to fill in the pieces. Remember that the exponent is an understood 1 here. So my degree is 1. Remember to name the degree. It'll be linear. The leading coefficient is a -1. So if I rewrite this, it's the same thing as saying -1x to the first plus 3. Okay. So the leading coefficient is a -1 here. My degree is 1. And then my constant is just a +3. Okay. So that's how you guys will fill in this chart. Please pause the video at this time to fill in the rest of your notes. This part is not in your notes, guys. It's just a special piece of information. Please know that when we name polynomials, they have special names. And one of the ways we name it is by the degree, and the other one is by the number of terms. And you'll see what I mean when we get to this chart. I'm going to go ahead and blow this up again. All right, let's look at the chart. So we have 12. Remember that if it's no variable there, it's an understood variable to a 0 power. So I just put x to the 0. So they're asking you about how many number of terms do you see. Terms are separated by a plus or minus sign. So if it's nothing there, no addition, no subtraction, then it's only one term. Okay. We name the term by either using monomial, binomial, trinomial, polynomial. Okay. Remember, mono means 1, bi means 2, tri means 3, poly means 4. Okay. So if it's one term, we're going to name that monomial. The degree, again, is 0. And then we name that degree by saying it's linear. I'm sorry. It's constant. I'm sorry. 1 is linear. Now, let's look at the next example. We have 8x to the first power. Again, it's understood 1 there because it's nothing there. So the number of terms, there's no addition and no subtraction here. So it's only one term, which again makes it a monomial. My degree in this case is 1. And so I name that degree by saying it's considered a linear function. This next one, we got 4x squared plus 3. It's two pieces here. You see it's a plus sign in the middle, so it's 1, 2. So the number of terms is 2. I name the number of terms. It's going to be binomial. By highest exponent, in this case, it's going to be 2. Remember that 2 is going to be a quadratic. Next example, we have 5x to the third plus x squared. The number of terms, again, is a plus sign here. So 1, 2 is 2 terms. We name that by binomial. And then my highest exponent or highest degree is going to be a 3. Okay. And that 3 is considered to be cubic. All right. The next one, we have 3x squared minus 4x plus 6. The terms, look, I got one piece here, I got two pieces here, I got three pieces here. You know, because it's divided by addition or subtraction sign. Okay. So in this case, we have 3 terms. Because I have 3 terms, it's a trinomial. My highest exponent is going to be 2 again, which makes it quadratic. This is the very last example. Again, we have 1, 2, 3 number of terms. We know because it's separated by a plus or minus sign. Okay, so it's 3. So it's going to be a trinomial. My highest degree is going to be 4, and it's going to be quartic, like quarts or quarters. If it's 4 pieces, guys, separated by addition and subtraction, remember that's considered a polynomial. If it's 4 or more, it's considered a polynomial. Okay, so that's pretty much it for today. Pause the video at this time. Let me go back. Pause the video at this time to fill in the chart if you haven't completed it already. The classwork. Okay, so you guys have 2 assignments. One of them is a graphic organizer, which you don't have to fill in, but it's actual work to complete on the second page. So you're going to complete the second page of the graphic organizer, and then you have another sheet that is attached to the back of your other graphic organizer note page. It's gonna ask you to draw shapes on the parts of polynomials. So that'll be the 2 assignments for today. And if you do not have a Delta Math account, please make sure today that you make a Delta Math account because you guys do have Delta Math assignments posted as of today on the parts of polynomials in the polynomial vocabulary. If you have any additional questions, please feel free to ask me during class time. Other than that, we have a closing. You're going to answer these 5 questions on the closing sheet. So you'll just delete the section on the closing sheet and answer the 5 questions. And then after you do that, then you will be finished, guys. And if you have any additional questions, please let me know. Have a great day.